Okay, so in this lecture, what we will apply is principal component analysis to the analysis of some countries and to see the relationship between these countries according to some characteristics. So the characteristics we have are about 100, almost 170 countries, and we have things like child mortality, exports. Child mortality is number of children that die before the age of 5 years, and then exports in millions of I don't know what, and then health. Somehow we have some number that encodes how good is the health in that area, and then imports, income is in dollars, so it is the average income per person. Inflation, life expectancy, total fertility, this is number of children per woman, and then the GDP per person. So we see that for every country we have these numbers, and then we remove the empty values. There is no empty value, and then we simply convert these two numbers that are integers, we convert them into floats so that everything can be input to the principal component analysis. So we start as always exploring the different the distribution of the different variables. So the child mortality, we see that it goes from 2.6 children per 100,000 inhabitants to 208, and then the exports, it goes from 0.1 to 200. Okay, so we can see the different values here. We can see also the different mean values, and then we start trying to analyze relationships between them. So for instance, let us go to some region where we can see the full matrix. So for instance, we see there are a lot of variables that are related, some others are not related. So for instance, let's see related variables. So for instance, life expectancy and child mortality. So if the child mortality is low, then the life expectancy is high. And on the contrary, if in a country the child mortality is high, so we move to the right in this axis, then the life expectancy is lower. And there is a almost linear relationship between these. There is also a linear relationship between total fertility and child mortality. So if child mortality is high, total fertility is also high. And when child mortality is low, then the total fertility is also low. And there is also an inverse relationship between GDP and child mortality. So when child mortality is low, the GDP per person is high, and when the GDP is low, the child mortality is high. So this is kind of 1/x relationship. There are some other variables that are unrelated. So it seems that child mortality is unrelated to inflation. We see almost a flat line, and the same here. Inflation is unrelated to exports, it is unrelated to imports, and so actually inflation doesn't seem to be related to almost any one of these variables. So yeah, we can explore many different relationships. This one is also interesting. So the income grows not linearly, it has kind of two regimes or even three regimes. So at the beginning, when the GDP grows, at the beginning the overall income grows, but then it seems to have two behaviors, one with a higher slope and another one with a smaller slope. Okay, so now we explore the correlation matrix. So you may remember that PCA is based on the analysis of the covariance matrix, and the covariance matrix is related to the correlation matrix. You can think of the correlation matrix as a normalized version of the covariance matrix. So here we have this kind of relationships only now for linear functions. So we are fitting lines to each one of these plots, and then we are measuring how good that line is representing the relationship. So if the correlation is low, that means that the relationship is not linear. So for instance, we have seen that inflation is not so much correlated to anything, and then we see that the correlations of the inflation are relatively low except to itself, while for instance child mortality was strongly correlated to some other variables. So for instance, it is strongly correlated to life expectancy and total fertility. So when the total so a positive correlation means that when the child mortality grows, the total fertility grows, and a negative correlation is the opposite. So when the child mortality grows, the life expectancy decreases. So these linear correlations that were linear, almost linear here, you see, you have this linear correlation. This is a positive linear correlation, this is a negative linear correlation. So those are the causes of these signs, this minus and this plus here, and the high values are implied by the fact that the relationships are almost aligned. So here, for instance, there shouldn't be a high correlation, linear correlation between GDP and child mortality, and we see that the correlation is not high, it is only minus 0.48, and the relationship is negative because when the child mortality increases, the GDP per person decreases. Okay, so we will later analyze this this correlation matrix with PCA. So here is a graphical representation of the same correlation matrix. Here with the heat map, we can get a better idea of which variables are related to which in which direction. So if you have a dark color, it is negative correlation. If you have a light color, it is a positive correlation. And then we can also explore what are the mean of these variables. So we have 38 children that are dying before the age of 5 in 100,000 people, and then the exports measuring these thousands of millions, and then health somehow encoded, and so on. So this is the average income in the world, and the GDP, I cannot see it here. Yeah, the GDP, or it is number 0. And then we have the export. So the standard deviations, we see what are the standard deviations of the different variables, and the standard deviations are important and the means, because you remember that the covariance is the expected value of the first variable x1 minus the mean of x1 times x2 minus the mean of x2. So this is the covariance, and the correlation is that value divided by the standard deviation of x1 times the standard deviation of x2. So all these means and standard deviation play a central role in the calculation of the PCA. Okay, so we will now do the PCA, and we import the necessary functions, and then this is the PCA. So this is taking the values that we need, and then what we are constructing is first a variable, a step that is scaling the variable. So this is computing the z-score of each variable. It is x minus the mean of x divided by the standard deviation of x, and these normalized function, these normalized variables, the correlation matrix and the covariance matrix are the same because of the way they have been scaled. And then the normalized variables, we compute the PCA. Okay, so here are the PCA components. So the PCA components is a new basis of that space. So we have a space with, let's say, 8 different input variables, and now we will construct a new basis for that space. And in this new basis, so this is the matrix that transforms one basis into the other. So here what we have are the transformation coefficients. So the PC, the principal component 1 is minus 0.47 times child mortality plus, remember that these ones have been normalized before getting into the equation. So this is the normalized child mortality, this is the normalized exports, and so on. And then we have 0.3 times exports plus 0.14 times the health, and so on. So we have to understand a principal component. We need to see which are the big coefficients and which are the sign of the big coefficients. So the largest coefficients here are child mortality, life expectancy, and total fertility, and maybe income. The other ones, let us consider them as smaller. So we already saw that child mortality, life expectancy, and total fertility, they are related variables. They contain the same kind of information, even in a very linear way. So for instance, here we saw that child mortality and life expectancy, they almost have a linear relationship, meaning that we can, given one, we can predict pretty well the other one. And then it is no surprise that they enter into the PC1 with almost equal coefficients. You see that the size is almost the same for the three of them because they contain the same kind of information. And then the other one, that was income, it has a positive value and relatively high. Okay, so let's see how, let us consider two situations, how a country can project a high value in this PC1. So because of the normalization, it needs, you have to read this as a value above the average or below the average, because the normalization is subtracting the average from each one of the variables. So how can you project high? So to project high, you need a high income, so that your high income is multiplied by a positive value. You need a high life expectancy, and then you need a low total fertility. So a low total fertility will be below the average, and then you have a negative value times another negative value. You will have a positive contribution to this projection, and the same for the child mortality. So you need to have high income, high life expectancy, low fertility, and low child mortality, and then you will project a high positive value. And on the contrary, if you want to project a large negative value, you have to be the opposite. You need a high child mortality, a high total fertility, low life expectancy, and low income. So along PC1, we should have a separation between rich countries and poor countries, and we will see that here. So let us look at the projected value. So here, this is PC1, so we should have here rich countries, and then on the other side we should have poor countries. Okay, so what about PC2? So PC2, we should, to project high here, we should have high exports, high imports, and on the other side it is not so clear, but on the other side you would need low health and low life expectancy. So and then that is to project high. To project low, you need low exports, low imports, and then on the other side, high health and high life expectancy. So not high, but above the average. So in PC2, we should have, if you want to project high, you need high, mostly you need high exports, high imports. So Malaysia and Cote d'Ivoire, for some reason they export high, and on the other side you need to have low imports and exports, and then you have Argentina, Colombia. Surprisingly, you have Spain there too. Okay, so this is one use of the PCA, so to understand how different countries separate along different axes, and then you can interpret the different axes. It's up to you the interpretation of the different axes, but you have to look. So you have to. So the PCA only tells you there is a big separation between there is a large variation of countries along this axis for some reason, and you have to find the reason. And the reason is found through looking at the big values and the sign of those big values in the coefficient. And we can show that matrix visually. So here it is the same matrix, but now in a visual way. We can also project original variables onto the axis defined by PCA1, PCA2. So for instance here, if we look at PCA1, PCA2, the first variable would have this coordinate, minus 0.47, 0.21. So we would have here minus 0.47, 0.21. So child mortality would be there. And you can do the same for the other variables. So in these kind of projections, similar variables tend to have similar directions. So for instance, it doesn't mean that we are projecting from an 8-dimensional space and onto a 2-dimensional space. So we have to be careful with over-interpreting what we see, but typically it is like that. So it seems that imports, income and inflation, they have the same kind of information, while child mortality and total fertility, they also have kind of the same kind of information. Exports and life expectancy, the important thing is the axis. So even if they have opposite signs, but they seem to be related to, but as always, you should always be careful with overinterpretation. So for instance, if we want to see if this is a real relationship or it is just an artifact of the projection to a 2-dimensional space, we should go to the scatter plot to see. So for instance here we would go to the scatter plot. We were interested in exports and life expectancy, so we go up, we look for exports. Where is export? Export is here and life expectancy is there. So actually they don't seem to be very much related. So these apparent relationship and on the same axis is simply an artifact of projecting an 8-dimensional space onto a 2-dimensional space. But for instance, this other relationship between total fertility and child mortality, that is really clear here, it also appeared in this plot. So you have to look at both graphs, this one and the other one, and the scatter plot, to make sure that your interpretation is correct. And then we can make the same kind of analysis for PCA3, PCA4. So the coordinate of a variable in that plot would be, for instance, this one would be minus 0.099, 0.11. So child mortality here should be there. So it is let's see, minus 0.099. So this seems to be a mistake, I think. So maybe I'm taking here the wrong component, but it doesn't seem to be what I expected. Okay. Okay, so now another interesting analysis that we can do with PCA is how many independent sources of information we have. And for doing that, what we look at is that they explain variance. So the first component, the separation between rich and poor countries, accounts for 45% of the variance. And this is quite a lot of variance for a single component. And we see that this poor rich is the variable that mostly explains the variability between countries. And the second next is actually rather far from the first one, but it explains also a lot of variance. Same for the third. And sometimes you see some kind of elbow in this graph, and then that is a clear indication of which is the number of independent sources of information. And components with very low variance, like 7 and 8, they're typically just related to noise. So we shouldn't trust them too much. So yeah, so instead of the fraction of each one of the components, we can look at the cumulated variance. So this is the cumulated variance with only the first. This is first and second, this is first, second and third, and so on. And typically you take a threshold around, depends on the application, but it can be somewhere between 0.8 0.95. So if you want to keep a lot of information, you keep 0.95, and the last three you would remove because they are simply sources of noise. And in some other applications, you may stop at 0.8, for instance, and then here you may stop at the third component, and you wouldn't interpret the last ones. So now we already saw this, that you can project each one of the countries onto the PCA, and then they will occupy a location in this new basis. And then in this new basis, we already saw the separation between rich countries and poor countries, and countries exporting a lot and countries not exporting so much. And with the high, it was imports and exports, so it was the balance between the two. Okay, and we can do it in PCA 1, PCA 2, we can do it with PCA 3, PCA 4, PCA 2, PCA 3, whatever combination of axes you want. So this would be all for this first introduction, and see you next time.